Coding example. Certainly, recursion is a program technique where a function calls itself to solve a problem. Here's an example C++ example of a recursive function to calculate the factorial of a number. In this example, we have a function factorial that calculates the factorial of a non-negative integer. The base case checks if n is 0 or 1, in which case the factorial is 1. If n is greater than 1, the function calls itself with a smaller value and multiplies it by n to calculate the factorial. The main function takes user input for a non-negative integer, calculates its factorial using the factorial function, and then prints the result. When you run this program and enter a non-negative integer, it will use recursion to calculate and display the factorial of that number. Recursive GCD coding. Certainly, here's a C++ example of finding the greatest common divisor, GCD of two numbers using a recursive function. In this program, we have a GCD function that calculates the GCD of two integers a and b using recursion, where 2. The base case is when b becomes 0, in which case we return a as the GCD. In the recursive case, we call the GCD function with b and a b, which is the remainder when a is divided by b. This step continues until b becomes 0. The main function takes user input for two positive integers, calculates their GCD using the GCD function, and then prints the result. When you run this program and input two positive integers, it will use recursion to find and display their GCD. Hanoi is a classic problem in computer science and mathematics that involves moving a stack of disks from one PEG to another, subject to the constraint that only one disk can be moved at a time, and a larger disk cannot be placed on top of a smaller disk. Here's a C++ implementation of the Towers of Hanoi problem using a recursive function. In this code, the Tower of Hanoi function is defined with 4 parameters, where 2. The base case is when there is only one disk to move. In this case, it directly moves the disk from the source PEG to the destination PEG and prints that move, where 3. In the recursive case, it follows the step of the Tower of Hanoi algorithm. Move N1 disk from the source PEG to the auxiliary PEG using the destination PEG as auxiliary. Move the NTH disk from the source PEG to the destination PEG. Move N1 disk from the auxiliary PEG to the destination PEG using the source PEG as auxiliary. Therefore, in the main function, the user is prompted to enter the number of disks, and the Tower of Hanoi function is called to solve the problem for the specified number of disks.